Hello everyone. So today I'll just be doing this single problem is differentiation, including law of logs. Okay. So yes, don't let this kind of problems intimidate you. So basically, there are certain rules that we will follow in regard of this problem. So regarding this problem, you should know the law of logarithm. Okay. You should know that d over dx. Okay, d over dx of ln of x. Okay, d over dx of ln of x is basically equal to 1 over x. Okay, let me write it down so that you can see it. Okay, is basically 1 over x. You should always know that. Okay, and okay, let me just explain it further. Okay, so how we come to 1 over x. Okay, we basically derived the x. Okay, we derived the x. Okay, and wrote x as it is as our denominator. Okay, basically, yeah, that's all I can say. Okay, yeah, so I'll just explain some other law of logs. Okay, which you should already know that the natural log of x to the power of x is basically, okay, is is basically equal to x ln of x. Okay, you should always know that. You should always know that. Okay, in fact, note that down. Okay, and also you should notice that let me use the pointer. Okay, you should also notice that here I have used d over dx, and here I did not use d over dx. It is because this one, okay, the second one, this one is the law of logs, and that one is basically the derivative. Okay, so yes, let me just write other law of logs. Okay, so that we can actually wrap up that particular problem. Okay, you should also know that the log of x. You should also know that the log of x multiplied by x. Okay, the log of x, let me use the bigger bracket here. Okay, you should also know that the log of x multiplied by x is basically equal to ln of x plus ln of x. Okay, these are the very simple law of logs that you should take into consideration when you when you encounter this kind of problems, this kind of derivative problems. Okay, is basically equal to this. Okay, ln of x plus ln of x. Okay, and you should also know that ln of x. You should also know that ln of x divided by x is basically equal to okay, I'm having a little problem with the ink, but I will sort that out. Okay, it's basically equal to ln of x minus ln of x. Okay, don't worry about my handwriting. Okay, it's just this platform. Okay, yeah, you should also know this little problem with the ink, but yeah, this is basically what we have. And also take this into consideration. Okay, write the brackets. Okay, the brackets before you can write the particular factor that you should write. Okay, okay, let me go to the problem now. I'll go to the problem. Okay, basically here we are given y is equal to x to the power of x. They want you to derive this kind of problem. Okay, so basically this problem It's very simple basically. You just have to follow this law of logs, okay? You just have to follow the law of logs, then basically you will be done. So there's something that we are going to insert. Because we are given x to the power of x, we are going to insert ln both sides, okay? Natural log both sides, okay? And also note that what you do on the left, okay, you should also do on the right, okay? That is the basic rule of mathematics, okay? What you do on the left, you do on the right, okay? So here we are going to derive this particular problem, okay? So let me just write this down. Ln of y, okay, is equal to, okay, when it comes to, yeah, here we are going to follow this law, okay? This law of ln of x to the power of x is equal to x multiplied by ln of x, okay? This is the law that we should follow here, okay? So yes, basically we will have x multiplied by, okay, ln of x. This is what we have. This is basically what we have according to our law of logs, okay? So yeah, here we are going to derive this particular problem. We are going to derive ln of y. Yeah, we are going to derive ln of y in terms of x. Basically, it's going to be the y over the x, okay? Basically, is what we are looking for. We are looking for the y over the x, okay? Okay, when deriving y in terms of x, okay, when deriving x in terms of y, you always put the y over the x, okay? So here we are going to have multiplied by 1 over y, okay? Like what I have shown you there. I have shown you that the derivative of ln x is 1 over x, but here we are deriving y is going to be 1 over y, okay? So yes, so here we have two parts. We have two parts here. We have x multiplied by ln of x, okay? So basically this is what I've shown in the previous video. This is what I have shown in the previous video. If you have not watched it yet, so make sure you go and watch it, okay? This will be our f, okay, and this will be our g, okay, meaning our f is x and our g is basically ln of x, and we are going to use f multiplied by g to differentiate this particular problem, okay? This is becoming implicit differentiation, okay? Basically we will use f prime multiplied by g plus f multiplied by g prime, okay? This is basically what we are going to use, okay? So let me use a red color to finish the problem. I hope you get the idea of what I'm talking about, okay? So basically we use this formula to derive this particular problem. Then we have the f prime, okay? Our f is x, then when deriving x is going to be 1, okay? E over dx of x is 1, then g we leave alone, yes, as the formula shows, okay? It will be 1 multiplied by ln of x, basically. This is what we are going to have, okay? Then plus, then x we leave alone now, okay? We're going to leave x alone as it is. Then we derive ln of x, since it is our g, okay? Derivative of ln of x is basically 1 over x, like what I have shown there while giving an example, okay? This is basically multiplied by ln of x, okay? Let me put the brackets so that you can basically understand, okay? I will use another color to put the brackets, okay? So basically we are going to have something like this, yes, something like this. Excuse me for my handwriting, so basically this is what we are going to have. I want you to get the idea of what I'm actually talking about, okay? With this problem you might actually master every upcoming problem that you encounter. Okay, you just have to practice. Okay, yes, this is what we have. We have something like this. Okay, then here we are going to have something like this. In any case, I hope you get the idea of what I'm talking about, regardless of my handwriting. Okay, so basically, let me use the red color so that I do not confuse you. So basically, we're going to have dy over dx. Okay, so basically, when I'm solving this problem, make sure you also pause the video and try to solve them by yourself in order to understand. Okay, in order to understand. So basically, here we are going to have multiplied by 1/y. Okay, multiplied by 1/y. Okay, I want to do this step by step. Okay, so that I do not confuse you. Okay, we are going to have something like this. So yes, 1 multiplied by ln of x is basically ln of x. Okay, ln of x. Okay, and make sure that you write the brackets, yeah, the brackets in the yeah, like this. So I won't be writing them looking at the time, but I hope you will write them. Okay, since you you need to write neatly. Okay, neatly. Okay, right. Okay, no master of pronunciation. So basically here, x is going to cancel x, since it's basically 1 over x multiplied by x. Yeah, I hope you get the idea of what I'm talking about. We are going to have plus 1 there, plus 1, something like this. This is basically what we have done so far. But because we are looking for dy over dx, not not for dy over dx multiplied by 1 over y. So we are going to multiply both sides. Okay, we will multiply both sides by y in order to, okay, to make dy over dx the subject of the formula. So basically, I will use the black color here. Dy over dx dy over dx is basically equal to ln of x. Okay, like I said, we multiply both sides by y. Okay, we multiply both sides by y in order to make dy over dx the subject of the formula. Okay, this is what we have here, something like this, plus 1, something like this. Okay, you put the brackets, um something like this, multiplied by y. You will have something like this. But because we do not want y in our answer, okay, we do not want y in our answer. We are differentiating x in terms of y. We do not want y in our answer. So basically, from our equation, we are given y is equal to x to the power of x. So basically, our y is equal to x to the power of x. We are going to substitute it. We are going to substitute x to the power of x uh, instead of y. Okay. So basically, what I am trying to say is, okay, let me write it down. What I'm trying to say is we are going to have something like this: dy over dy over dx. We're going to have something like this as our answer. Okay, ln of x plus 1. Then we substitute x to the power of x. This will basically be our answer. Okay, this is our answer. So yes, this problem comes. It may come in your exam. Okay, they always come, this kind of problems. Okay, you may find them at 5 or 6 marks. Okay, yeah, 5 or 6 marks. They always come. They always come. Okay, either in multiple choice, they may ask you, okay, they may give you the problem and ask you, what is the next step? Okay, they may ask you, what is the next step? So basically, you should know the full step of this problem. Okay, so thank you for watching my video, and don't forget to subscribe and leave the comment on the description. Excelsior.